Ladies and gentlemen, welcome back here, BASF at K22. Welcome to our plastics journey and welcome to our next creator talk for today. My two co-creators today are Alexander Fass and Michael Gepregs, both from our Ultraform business, but from business and from R&D. So we have the perfect combination to talk about innovation, actually about breathing new light into innovations. I'm excited what you mean by this title. We're going to start with you, Alex. This talk is about innovative solutions, as I mentioned. And we at K here, we are about a journey towards a more sustainable future. What role does Ultraform play in this journey?
Well, thanks, Richard. So, first of all, our innovations are very much guided by the needs of our customers and as well by the sustainability goals of BASF Group. And therefore, we have focused our innovation power on two topics mainly, which is on the one hand, the expansion of our specialty product portfolio. And in particular, we've invested into developing tribological grades. So grades for very demanding tribological applications with an excellent sliding friction behavior. And this helps us to save energy in the application. We will hear later on from Michael that it also avoids noise, squeaking, and as well avoids wear in the application.
Okay.
On the other hand, we focus very much on the development of sustainable grades. So we have there two new product ranges. On the one hand, Ultraform low PCF, so standing for low product carbon footprint. And on the other hand, Ultraform BMB for biomass balance.
Okay.
And both solutions contribute to a lower product carbon footprint and therefore for our customers to the reduction of their Scope 3 CO2 emissions.
Okay, okay. Michael, let's continue with you. Alex mentioned the tribological grades and you briefly touched on that, but I'd like to hear a little more. What is tribological application or grade?
Yeah, good question, Richard. So tribologicity is the science of friction and wear. And you can imagine, this is the bridge over to sustainability. When there's friction, you need more energy to overcome this friction. And when you have tribological optimized grades, you can save energy and hence we have more sustainable product portfolio.
Okay, and in which applications does that play a major role?
This is a multiple relevant criterion in most industries. So we have pictures for transportation industry, consumer electronics, the gear parts which are working and moving, but also medical applications, conveyor belt applications, we have in mind. So multiple areas are attractive.
Is the impact of such a modified grade on less wear and less friction, is that actually something you can quantify?
In some cases we can, definitely. So the wear, of course, so all of us has a picture of like a desktop printer, So when there would be some plastic wear, so you will have dust in your printer, No one likes to have dust in your printer, And therefore, when you have a material with less wear, with the gears working hand in hand together, this would be definitely an advantage for the customers.
Okay. Well, Alex, back to you. I mean, you mentioned the drivers for these developments. You mentioned low PCF, you mentioned the biomass balance product portfolio. How much requirement are you getting from customers? How much need is there for these grades?
Yeah, so it's definitely increasing. I think the whole, let's say, movement towards sustainable grades has gained a lot of momentum. I mean, it's been around for several years, but really, let's say, from a year ago until today, it's been exponential. The demand, the increase in interest in the topic. So therefore, we also are today launching these two great solutions for our customers.
And Michael, let's go a little more into the details of the actual grades, from the big picture to what actually you have in store for your customers. Can you tell us a little more about the actual grades and what they can do and what they can't?
Yeah, so maybe we started really our journey with a very limited portfolio in tribological optimized grades. And we got a lot of requests, what Alex also said, from customers requiring such grades. And so this was the driver for us to start a development initiative and to offer solutions for the customers in different areas, like silent performance, like medical, like good mechanical properties. This was our target session.
Okay, and then How did it continue?
And then we made it real, yeah. So we really developed 4 new categories. So we had our well-known Ultraform TR crates called immediate response. So this is stick-slip behavior, yeah. So when you have moving parts that is really very smooth moving from the very beginning. So we enriched this portfolio. Then the TRE portfolio, a new one. This is for high mechanical strengths, where we had a special focus on providing good tribological performance and additional good mechanical properties. And then we have a very nice one, silent performance, and maybe you hear it.
Can you hear the squeaking on this one?
It's a little bit squeaking, yeah. And this is the optimized version, where you hear nothing, yeah. So, and you can imagine, you know, maybe all of you know, so the windscreen wiper, yeah. So it's this boring squeaking noise in front of you. This is disturbing for all of us, yeah. And when you then can provide a non-squeaking solution for the customers, this generates more comfort.
I just wanted to ask, okay, yeah, I get the point, but what's it used for? Okay, now, but you answered that question.
But, and let me finalize with the TRF series. So the TRF are polytetrafluoroethylene modified crates, and this is especially a combination of very high load and good friction behavior. Targeting a little bit the application of conveyor belts, yeah. All of us know the Amazon big stations in the world, yeah. There are a lot of movements going around, and when we can provide solutions for this, could be beneficial. And let me conclude, again coming to sustainability, all the crates which using less energy to move these parts really save power and save at the end of the day product carbon footprint.
Yeah, and I mean that's a specifically important point at this point in time, I would say. Yeah. Alex, I'd like to go back to 2 points with you, actually. Sure. One is, again, a little more on the low PCF portfolio, on the decarbonization efforts that you are undertaking, and one would be on the global scope of your business, like are the requirements similar from region to region? Yeah. You can answer the second part first, if you like.
I think I will do so.
Okay.
Thank you. So basically, the trend, I think, is global. Yeah. So there is maybe a little bit different speeds in the different regions. I think Europe is leading the way, at least in many aspects. But also, really, we're getting increased inquiries also from Asia and all the way also to North and South America. So it's maybe at different speeds, but it's really gaining momentum across the globe.
Okay.
And maybe now the first part of
you still remember it. That's good.
I think so. So our plastics journey is also really a journey towards more sustainable solutions, and for us concretely, for Ultraform, it's a journey towards offering a net zero product carbon footprint for Ultraform. Yeah? We're not there today, but it's our goal to offer a net zero by 2024. So, and the journey really started last year, where we said, first of all, we want to create transparency. To establish the baseline of the PCF of our conventional fossil grades. And we ran a comprehensive life cycle analysis, which shows that our conventional grades have a very good product carbon footprint of below 3 kilogram of CO2 equivalents per kg of Ultraform. We believe that's a very good value, and it's driven by our energy efficient production technology.
Okay.
But then, having said that, of course, we're looking for opportunities to really significantly reduce our product carbon footprint. So the first step was to work with renewable energy. And this has a particular high leverage in our product carbon footprint, because POM is a very energy intensive process, right? Okay. So if we use a lot of electricity, a lot of steam, so when you then go to renewable energy, you can imagine you have a pretty accentuated reduction in your PCF. That brings us to below 2 kg CO2 equivalents. And then the second big aspect to our PCF in POM is, of course, the main raw material, methanol. So then looking at methanol, in the next step we work with biomethanol based on biomethane, so renewable feedstock in our production chain, which allows us to reduce another roughly 1 kg and brings us to a very interesting value of below 1 kg of CO2 equivalents.
Okay.
Yeah. And in the last step, that's not where we want to remain, let's say, with our offering. So as mentioned earlier, we're really focusing on getting to a net zero offering. And we will utilize new methanol technologies like e-methanol. E-methanol is basically leveraging green hydrogen and also in combination with CCU technology, so carbon capture and utilization. So you can imagine if you take out CO2 emissions out of the atmosphere, that it has a very, very favorable effect on the PCF.
Okay, so I assume, Michael, you're the one who has to develop the products to reach the target by 2024?
I'm not the one who developed the products, but I'm leading a team who are doing this development of the products. Yeah, so we are working as one global team together. Yeah, and yeah, make good progress in this way.
Okay, so on a scale from 1 to 10, how optimistic are you that you will have zero footprint products by 2024?
10.
You look at me, it's fine, so I give it a shot. I think it's a very high probability. So I would say it's above 90%. Why is it not 100%? Because e-methanol is not widely available in commercial quantities yet, but I think it's really leading the future. Yeah? It's a technology that's being rolled out. There are around the world a couple of pilot plants. But of course, we have to test the material. We have to also rely on that getting mature, and available in significant quantities, basically. Yeah.
Is this also something, I mean, when we're coming back to the main topic of our plastics journey, also meaning that we have to cooperate and work with partners outside of our traditional value chain? Is this an area where we have to take a broader look and talk to people we haven't been talking before?
Yeah, it's actually very interesting because you actually have to be, of course, very closely linked to the suppliers of e-methanol, or it's not only e-methanol, there are other technologies out there as well for methanol that have a favorable product carbon footprint. So of course we work with partners, not only in BASF but also externally on that field. And then also very interesting, some leading customers in the topic of reducing the product carbon footprint of their products, they actually go so far that they work in the value chain, right? So they also identify the most interesting methanol technologies and then work with BASF to really orchestrate, let's say, the full value chain.
Last question to you, Michael. I mean, you've done a couple of interesting things at BASF so far already. How interesting are these times to be responsible for your area right now?
Very interesting. I think especially what I said, the bridging of not only the pure mechanical properties. So in the past, we always focused in the engineering and plastic areas, taking care of mechanical properties, better impact strengths, better tensile strengths, whatever, yeah? And now bridging this together with the sustainability approach, what Alex mentioned and what we have with our tribological grades. I think this is really living our claim, what we have in our company, yeah? And I'm happy to support here. Yeah.
And also creating basically a totally new product feature or a new currency, which is CO2, after all. Gentlemen, thank you very much for the insights into how you breathe light into innovations with Ultraform.
Yeah, maybe if you allow me one more comment here on the concrete.
Stage is yours.
Thank you, Richard. So on the offering of the new sustainable grades, right? We talked a little bit about what we've done, how we've reduced the product carbon footprint, but I just wanted to show very quickly as well the concrete offerings that we have now, and at the occasion of K-Fair we are launching these in the market, and they follow very much the logic of what you have seen of our journey of the CO2 reduction. So we offer now Ultraform low PCF, so really leveraging renewable energy, and here the value proposition is really very clearly on an efficient reduction of the product carbon footprint. So customers who want to efficiently focus on the reduction of the product carbon footprint, their scope 3 emission reductions, that's the right product. You save roughly 30%, or actually at least 30% compared to a conventional Ultraform grade. So this is, let's say, one option, and the other one is a BMB option. So it adds to the, let's say, to the low PCF version also the renewable feedstock. And therefore, we can create a reduction of remarkable 70%. Yeah? And this is ISCC Plus certified, so it guarantees the correct attribution of the renewable feedstock really to our final polymer, the Ultraform BMB product. And the best thing is as well that there's no difference in quality or performance to the conventional grade. So let's say, not necessarily a requalification for our customers is necessary. You can use, if you have the conventional product qualified, write these as drop-in with the benefit of the Scope 3 reductions in emissions.
So whichever way you choose, low PCF or BMB, the direction is clear. And it's the right direction, it's the direction towards sustainability. Again, thank you very much for giving us insights into what you are planning on our plastics journey. You'll still be around for questions. For the moment, I thank you a lot.
Thank you.
Thanks, Richard.
Yeah.
BASF. We create chemistry.